This is the fourth of the 10 questions, and it's this one. If you want to pause the video and have a go at it, you can do so. Otherwise, I'm going to explain it. So, a trigonometric function is given as y equals 7 sine of x plus a. So we get y equals 7 sine x plus a. And we want to find the value of a such that the maximum value of y is 4. Some sketches would help, but you don't have to do these. It's a 1 mark question. So I'm going to do this in potentially more detail than you would, but I'm doing a demo of this. What we first want to do is consider the graph of y equals sine of x. And y equals sine of x looks like this. So that is y equals sine of x. And the maximum is 1 and the minimum is -1. And x is in degrees. So at this point is 0. This is 90. So when x is 90, y is 1 and it's at this maximum 180. If x is 180, again, y is 0. If x is 270, then you get -1. And at 360 is equal to 0 again. So that is the graph of y equals sine x. Now, if we have the graph of y equals k sine of x, then it's going to look the same shape, but we get this instead. So your maximum is k and the minimum is -k. We now have y equals k. So we are stretching it in the vertical. And again, that's 90, 180, 270 and 360. So the values which it cuts the x-axis does not change. It's still 0, 180 and 360. The only thing that changes are the maximum and the minimum values. But suppose we have y equals 7 sine of x. We'll leave out the plus a bit and we'll change x. Let's change x. Oh, sorry, let's change k, not x. K is 7. So we can replace the k and the k here. We have a maximum of 7 and a minimum of -7. But we have to find the value of a so that the maximum value is 4 instead of 7. I do know I'm spending a lot of time on this, but it's one of these ones you really want to visualize. So the red one is y equals 7 sine A. Again, I'm not going to emphasize all of the values along the x-axis because it's not relevant for this. Well, it's not relevant for this point that I want to show you. The idea is if we have the graph of y equals 7 sine of x plus a. Now the plus a means that the graph shifts up a in the vertical. We have 7 sine of x plus a. So if it's plus 1, the whole thing shifts up 1. If it's plus 5, the whole thing shifts up 5. So we need to shift it either up or down so that the maximum is 4, not 7. So if we go down by 3 and we keep the same shape, then the whole thing's then shifted down by 3. So the maximum is 4. It intersects the y-axis at -3, and the minimum is -7 minus 3 is -10. And this is the graph of y equals 7 sine x minus 3. And we have a look, 7 sine x plus a. So a must be -3 because it's being shifted 3 down. Put this in red pen, in fact. Being shifted down 3. And let's have a look at part B. We said, hence find the x coordinates of the points of intersection between the graph of y equals 7 sine x plus a and the line y equals 2. So let's start off by writing the equation with the value of a that we found substituted. And we have y equals 2. Now these two graphs, and I call y equals 2 a graph because although it's a line, it's a horizontal line parallel to the x-axis, it's still a graph. Now if we want to find the points of intersection, we have to equate. So we have y and we have y, so we can equate these two. And this would be the second mark. I say the second mark because it's the first mark in B, but part A was 1 mark, so A would be mark 1. I should write that in actually. So this would be number 1 and this is number 2. So then what we want to do is, well, we can add 3 to either side because we want to get sine x on its own. We want sine x on one side on its own. We have -3, so if we add 3 to both sides, we cancel out the -3, so we get 7 sine x is 2 plus 3, and that's equal to 5. And the 7 is multiplying on the left hand side, so let's divide both by 7 to cancel it out, and we then have sine x on its own. And that is the third mark. Now, what we want to do is we want to consider what's known as a cast diagram. We're going to consider cast. I've done this in other videos. And the idea is that all the sine, the cosine, and the tan are positive. So I'm going to make this as sine. This is cosine, and the purple is tan. So that's positive, and because the blue pen represents sine, the sign is negative and negative. The cosine is positive in this one and in this one, but it's negative in this one and this one. The tan is positive in this one and this one, and it's negative in this and this. We have that the sine of x is positive, so we're going with this one and this one. The next thing we want to do is we want to find the inverse sign of the positive value on the right hand side. Now this is positive, but suppose we had the equation sine of x equals -5/7. You still want to put the positive, or what's known as the modulus. So the modulus of a number is take away the negative if there's a negative. So the modulus of 5/7 is 5/7. The modulus of -5/7 is 5/7. But we don't have to worry too much because we do have a positive. And making sure to have it on degrees and not radians, you're going to plug that into the calculator, and we're getting 45.58 degrees. There's no mention of rounding in the question, so we can stick with this if we choose. Now, if it's positive in the A, then you just keep the same value that you found here. So this is the first solution. So the first solution in that quadrant is 45.58. And the S is 180 minus. Now, because it's positive in this quadrant, we then get 180 minus is the second solution. We would get the fourth mark for getting 45.58. So this solution is the fourth mark, and to get the last mark, all you have to do is evaluate the other solution, and that is 134.42. And that's the last one. So I hope you found this video useful, and I'll show you quickly what we did. So it's just about transformations of the sine curve and solving this equation in a slightly unfamiliar context. But the idea is the intersection of two graphs, you just have to equate them as shown. So thank you for watching, and the best of luck with the studying.